We're gonna find it. We're gonna find what's going on. Hey, my name is Ben. Thanks for stopping by. And especially welcome to any of you guys who are new to this channel. I know that a lot of people have joined in the past couple of weeks. Thanks in part to the video that went up and actually did perform pretty well. So thank you so much for watching that video, for commenting, and all of your thoughts. If you did not see that video, I'll link it in a card right up here and you guys can watch that. Now the topic of today's video is directly related to that previous one in that we had a little bit of current. Thank you guys for correcting me on my terminology. I'm trying to do my best. We have some current that is still leaking to ground even though we have all of our neutrals and ground wires separated inside of this sub panel. So what I'm going to do is I'm going to go through the list of suggestions that you guys had in finding and figuring out where that stray current is coming from. One of the top comments was just to turn one breaker off at a time until we figure out or see that that current goes to zero, and then we should be able to track down which appliances could be causing the issues. The bridged neutral in a box somewhere. So if we had a neutral and a ground wire that somehow were connected together in one of the electrical boxes somewhere in the house, that could cause additional current to flow to ground, and that could be what we're sensing here. Now I don't think that that's very likely because the vast majority of my breakers are arc fault or ground fault, and any arc fault or ground fault circuit breaker like what we have in here will trip if there is that occurring. If there is a neutral and ground connected in a box somewhere, my breakers would be tripping, and so I don't think that that's likely, but it could be. Now, one that was mentioned by several different people is the possibility of it being an induced current. When you have parallel wires going through a system, especially inside of a raceway or a conduit, that can generate inductive current. Now, I am not an expert on inductive current. I want to learn more about it and maybe make a video at some point. The water heater was mentioned as a possibility if one of those elements is leaking some current to ground. EMI filters, which are electromagnetic interference filters, and apparently they use a Y-class capacitor, and with that that capacitor or that EMI filter can put some power back onto the ground, and that is by design. Now I don't really know what I'm talking about here, so we'll just see what we are able to track down. Now this is a super interesting one, difference in potential between two sets of ground rods. Now a bonding strap being connected in an appliance is another possibility. That could be like a dryer or an electric range where they are designed such that they can be used with a 3-wire cord or a 4-wire cord, and there's a bonding strap that connects the neutral and ground inside of that appliance, and if that was not removed, then you could see the situation where some of the current is going back on the ground wire. So before we figure out where this current is coming from, I want to put a poll right up here so you guys can click on this poll and you vote on which thing you think is the most likely scenario or the most likely problem. Obviously I will know the answer. I don't know the answer yet, but I will know the answer when I publish this video, so I'll make sure that the correct answer is in there. So go ahead and vote, and then we will see what we actually track down. Thank you to whoever pointed out that this is not an amp meter, this is an ammeter when you're using it in the amp measurement mode. So we're going to put that into our ammeter mode, and then we're going to clamp it around our EGC going out to the panel outside, and we'll see how much current is currently being carried. And you can see right there we're at like 0.17 amps. Earlier when I checked it, it was at like 0.22, so it's obvious that there is some difference depending on what is running at any given moment. So we're going to go through and start shutting off breakers coming down this side, and we'll see which circuit is the primary culprit. Okay, so here we go. Starting at the top, I'm turning off the septic pump, sump pump. The furnace was already off. Upstairs bathroom, main level bathroom, upstairs laundry room, basement laundry room, attic and kids' bedroom receptacles, master bedroom and hallway, living room and stair receptacles. I think this next one has a good chance of making a difference. This one is the circuit for the office, which has lots of electronics in it, so we'll see. If it was an EMI issue, I'd expect it to be coming from some kind of a piece of equipment, so we'll turn that one off. And not really. So turn off the office circuit, and it didn't really change much at all. Alright, we'll keep going down here. Here's basement receptacles. Outdoor receptacles is next. And I have 3 different freezers plugged into this circuit, so I don't know if they would have an issue. Nothing at first anyway. Now we are to the kitchen circuits. So I have my first kitchen circuit, second kitchen circuit, third kitchen circuit, the dishwasher, attic and upstairs lights. So this is a lighting circuit. There are several dimmers on that, and some people had mentioned that dimmers could be involved in this situation, so we'll check that. Not that one. Now we're going to be turning off the main level lights. Again, additional dimmers on that one. That did not have any effect either. Okay, so we're down to our last circuit that is for just a regular 120 volt circuit, and that is the lights in the room we're standing in right now, so it's going to get a little bit darker. It's basement and outside lights and smoke detectors. Okay guys, we're down to 240 volt circuits now, and we're still drawing some power, no, not power, some current on that EGC. So we'll keep going. So we're at 0.16 amps, and we'll start turning off our 240 volt circuits. This is the upstairs dryer. Right now there's not an electric dryer plugged into this circuit, but nothing there. And now we'll be turning off the electric dryer in the basement. Now I kind of wonder if this is a possibility because it is an older dryer. It does have a 4-wire cord on it though, so it should be fine, but here we go. Didn't change a thing. And see that the amp draw actually went up a little bit there to 0.21 now. So here we go, electric range. Didn't change it at all, and actually I do not have an electric range plugged in right now either. Okay, here comes the water heater, and I think there's a possibility that maybe this is our culprit. We'll find out here. No. 0.19 amps still. Alright, the last circuit in our entire panel here is the heat pump outside. Air source heat pump. Here we go. Huh. It's still the same, you guys. It's still the same. No! What is going on? Alright, well let's turn off this main breaker just for a good measure. Here we go. The one thing that this is going to kill when I shut off the main breaker is it's going to kill the power to all of these GFCI and AFCI circuit breakers, because these draw like, I don't know exactly, but they draw a little bit of power in order for them to work. I'm not sure if they draw power even when they're turned off or if it's just when they're turned on, but actually what we'll do here, I want to pull this this surge breaker out and see if that makes a difference. So you guys can see that we're at, our amp draw has went up to 0.24, 0.22 now. So I'm just going to pop this this surge breaker out here and see if that has anything to do with what's going on. Very carefully. That did not change it at all either. So interesting. I'm going to snap that back in. Did you guys know that these surge breakers are now required in new installations based on the 2020 code, or at least my understanding of it? So if you guys want to see how to install a surge breaker, I will link to that video right up here, and we can talk about that some more. So go ahead and click on that, and we'll see you over there after this video. Alright, now we're turning off the main breaker. Here we go. 0.19. We're still getting power. No, not power. Current. Current is still flowing. 0.19 amps. Let's just take this off here. Oops. And there it went to 0. So I think what we're going to do now is measure to see how much current is here. We got 0.2, okay. And now we're going to measure the current flowing on each of these. This should be absolutely 0. So let's just check it out really quick. Well, yep, it is. It's a 0. 0 there. These ones are kind of hard to get around. This one is totally 0. And this one's really hard to get around, you guys. I'm doing this for you. There we go. And 0. Okay, totally 0. So we're at 0.2 amps. And I have no idea why. There is obviously power flowing. No, not power, current. There's current flowing from outside in, like almost like it's coming back from the first panel out in the yard. So what we're going to do next is we're going to go outside and shut off the power at the first panel out there in the yard and see if that kills this or not. I don't know. I don't know what to think about this. This is crazy. This is so weird. All right, here we go. Let's find this. We're gonna find it. We're gonna find what's going on. This is what's cool though. What we did determine so far is that all of the devices and things inside of the house here are working correctly. There is nothing in my electrical system here that is bleeding current to ground. Okay? There's not anything that we really measured or nothing that I saw obviously where an appliance or something else was leaking current to ground. So that is cool. So we at least are on the right track in our troubleshooting process of eliminating that as a possibility. So let's go outside and check it out. Right now snow is melting and the sun is shining out on the field. It's melting the snow, but the temperature difference or something about it is creating this like fog slash steam stuff that is just rolling across the prairie here in southwest Minnesota. And it just looks so cool. All right, here we are out at the first panel out in the yard. I'm gonna go ahead and open this up. So I'm gonna shut off all of the circuits here. Find out if that took care of it. So inside of our panel again, now there's no power turned on at all. And oh my word, you guys, there's still 0.24 amps running through that stinking EGC. 0.24 amps. Guys, I do not understand this. There is still the same amount of current going through that ground rod as there was when the entire system was energized. We have the main breaker turned off outside that feeds this panel. We have every single breaker turned off inside of this panel and the one out there. And we are still getting current flowing through that wire. The wires that feed the panel inside the house come out kind of right underneath the front door, and then they're buried about 6 feet down, coming across over to this panel in the yard, which is next to the transformer and the electric meter. So right now we should be using no power at all on the property. Now, is it proper to call it power now at this point, since we're not really looking at wires? Or should I say we are using no current on this property? You can let me know down below. In any case, it doesn't look like anything's happening there. We're gonna pull this cover off and just take a few measurements and see if we can figure out what's going on. I forgot my ammeter. My ammeter is in the house. I'll be right back. I'm gonna go get my ammeter. Now you guys are going to get to see my Sense Energy Monitor, the way it's installed out here. I have a discount code for those of you who are interested in the Sense Energy Monitor. It's super awesome, but I'll try not to talk about that too much. But the link for that discount for subscribers will be in the description below. And since, if you're watching this, I'm sorry this is a non-conforming installation of the Sense Energy Monitor, but you guys are bound to see it at some point in time. Be extremely cautious when you're working in any live electrical panel, and I wouldn't recommend it unless you are qualified. Our power coming into this panel is this wire right here, as well as this wire right there. And so we'll go ahead and just test those to see if we have any current that is being drawn. So on this leg, we have 0.00 amps. Exactly what we would expect and hope for, given that our main breaker is turned off right there. And then right here, we are drawing 0.00 amps. Again, exactly what we were hoping for. Now, I wonder if we have any current that is flowing on this neutral wire, which would be coming from the center tap of the transformer. So it comes in and it's tied to the neutral bus, which is tied to our grounding system. Down here is where our grounding electrode is tied into this neutral bus. So if we had current that was leaking to ground, it could be maybe coming from that center tap of the transformer. I don't know. We're going to find out. Yes, I was right. You guys, we found it. Can you guys see that there? 0.4 amps is coming from the neutral wire, which is connected to the center tap of the transformer right over there. This has gotten so much more interesting than I expected it to. Honestly, when I started this, I assumed we were going to find some kind of electronic thing. I was thinking the EMI thing was going to be it, with or inductance or something like that was creating that weird load on the grounding system. But that current is coming from this transformer. The center tap of the transformer, which is the neutral, then goes into that panel and is tied onto the grounding system. So at that point is where that current gets dissipated through my grounding system. And any point at which there is a decent grounding electrode, some of that current is being distributed through that electrode. So we have electrodes here in the ground that are connected to this panel. And then we have grounding electrodes over here by the house that are connected to the panel inside there that we've been looking in. There's a ground rod right about here and a ground rod over here. So a percentage of the current is leaking through the grounding electrodes right there. Now, coming from the house across this open area back into the grove about 150 feet, we have a copper gas line that is acting as a grounding electrode right now because there is no dielectric union installed where that pipe goes into the ground. We're going to be solving that in a future video, so make sure you subscribe if you want to see that. But in any case, that's a very significant grounding electrode right now, and so we have a percentage of that 0.4 amps that is flowing into the ground through that grounding electrode. Because even with all of the circuits turned off, the grounding system stays fully connected. When you turn off a breaker, it only disconnects the hot wire and not the ground or the neutral. So this brings up a whole new thing that I do not understand, and it relates to whether or not electricity wants to go to ground. Now, we talk about electricity. I always wanted to find the shortest path to ground. It's actually not the shortest path. It's all paths back to the source, not necessarily to ground. But in this case, it is actually current that is flowing from that transformer and into the ground. So obviously there must be some way for that current to make it back to its source. So I don't know if that source could be those power lines way out there by the road. That's about 1,000 feet away, where the closest grounding electrode would be pounded in the ground. There's another transformer over there. The big power line going across there is actually a transmission line, and so I don't think that that one's involved, but maybe that transmission line has some kind of a grounding conductor that is being used for some reason. So right now that neutral wire is at 0.36 amps, so still a pretty good amount of current. 125.6 volts on one leg, reference to neutral, and 125.6 volts reference to neutral on the other leg. So we are very consistent there. So the good news about this is that it doesn't seem like my electric meter is counting this power usage. I'd have to like put a time lapse on it to make sure that it doesn't move. But as far as I know, it only monitors the usage on the two hot legs and not the power usage on the neutral. But I could be incorrect. Correct me in the comments down below if I'm wrong about that. But I'm pretty sure that that's how these meters work, is they just measure the two hot legs. Another interesting thing to me is that the amount of current flowing on that neutral varies. So right now we're only at 0.27 amps, 0.26, whereas earlier it was at 0.4. So it must just be the electrical system has some variance to it. I'm super excited to see what you guys say in the comments below, so I'll definitely be hanging out there as much as I can after this video goes live, and we'll be able to figure out what we need to research next to understand this a little bit more with the current flowing from that neutral wire and into the ground. So if you found this video to be interesting, make sure you smash that like button right down here and subscribe to the channel to see more videos just like this one. If you want to keep learning with me, click on one of these videos here on the screen. I will make sure to put the one where we discovered this problem in the first place. The boss just got home. I'm probably going to have to turn the power back on now, I guess. Whoa!